Uh, we will study how to connect resistor, inductor, and capacitor in series to an AC generator. We will study this title today. First, let's remember these components one by one when they are connected to a generator. So how electric current and potential difference related in these devices. First, let's remember the pure resistance in an AC circuit. When we connected a pure resistor to an AC generator, electric current and potential difference are in phase. So there is no phase angle difference between electric current and potential difference across a resistor. When a pure inductor is connected to an AC circuit, because of the self-induced current, the electric current lags behind the potential difference, or potential difference leads the electric current by a phase angle of pi over 2. So this is the electric current in the circuit. This is the potential difference across the inductor. So then the phase angle difference between potential difference and electric current is pi over 2. When a capacitor is connected to a AC circuit, in this time, the electric current is leading the potential difference. So potential difference lags behind the electric current by a phase angle of pi over 2. So this is how electric and potential difference changes in an AC circuit when we connect a resistor, an inductor, and a capacitor. Okay, now the question is this: what happens if we connect a resistor and a coil and a capacitor in series to an AC generator? So then how electric current and potential difference of the circuit changes? So a resistor, an inductor, and a capacitor are connected in series to a generator, as you see. So if three devices are connected in series, which means if they are connected one after another, so this is a series combination, so the electric current, the same electric current will pass through these elements, and all are L, C, yani resistor, inductor, capacitor, and even the generator will have the same electric current. But potential difference are not the same in parallel series combination. So VR is the potential difference across the resistor, VL is the potential difference across the inductor, VC is the potential difference across the capacitor. So potential differences are defined, remember, according to electric current. Because electric currents are the same, in series combination, I will define the potential difference VR, VL, and VC with respect to electric current in series circuit. Now, look at here. The electric current is defined in horizontal. So because the electric current is the same for all these three elements, but potential differences are different, like what? So in inductor, first let's start with the resistor. In the resistor, potential difference and electric current are in phase. But in coil, inductor, pure coil, pure inductor, potential difference is leading the electric current by pi over 2. In capacitor, potential difference lags behind the electric current by pi over 2. So this is the phasor of this RLC series circuit. So we are in phase with the current. VL is leading the current. VC lags behind the current. So now, as you see, there are three potential difference factors: VR, VL, and VC. So then VL and VC are opposite in direction. VR is perpendicular to both VL and VC. So now we will use a vector addition method to calculate the total potential difference. What is this total potential difference across the resistor, inductor, and capacitor by using vector addition method. Because VL and VC are opposite vectors, as you see that in opposite direction, the magnitude of the magnitude of the resultant will be subtraction, of course. We are going to subtract the smaller one from the greater one. So VL, I assume that VL is greater than VC, so that's why VL minus VC is the resultant of potential difference across the inductor and capacitor. So potential difference across the inductor and capacitor is equal to VL minus VC. However, VR is perpendicular to this vector, so that's why we are going to use Pythagorean theorem to calculate the total potential difference across R, L, and C. So the total potential difference across R, L, C is calculated by vector addition of VR, VL, and VC, and we will use Pythagorean theorem to calculate the resultant vector, which is total potential difference, which is equal to square, it's a right angle triangle, so this the V total is the hypotenuse. So the one perpendicular side is VR, so VR squared plus other perpendicular side is VL minus VC, that's why VL minus VC squared. So this is the equation for calculating the total potential difference across the resistor, inductor, and capacitor. And if we divide, because electric currents are the same for the generator, for the resistor, for inductor, for capacitor, because all they are equal. So I will divide these potential differences by I, because if we divide them, we get opposition of each device to electric current. Like this, VR divided by I is the resistor. VL divided by is the opposition of the coil, which is inductive impedance. VC divided by I is the opposition of the capacitor to electric current, which is the capacitive impedance. V total divided by I is called total impedance and represented by Z. So V total over I calculates the total impedance, which is the total opposition of resistor, inductor, and capacitor to electric current. So Z, it is represented by Z. It is equal to, so R squared, which is the resistance of the pure resistor, plus XL minus XC squared. This is the second equation, which is going to be used for calculating the total opposition of this RLC circuit to electric current. Total impedance also ohm, because it is again volt divided by ampere, so it will be measured by ohm in the circuit. So next step is to calculate the phase angle difference. Phase angle difference between the total potential difference electric current is not 90 here, so we need to calculate this angle, which is theta. So it can be calculated by classical method for finding the tangent theta for a right angle triangle, because both are right angle triangle. So theta is the phase angle difference between the total potential difference and electric current, so it can be calculated by tangent theta is opposite side of the angle, which is VL minus VC, divided by adjacent side of the angle, which is VR. So if we divide VL minus VC by VR, we will calculate the tangent theta. So which means theta must be inverse of tangent VL minus VC divided by VR. We can get it from potential differences, but one more way, we can use the phasor for the phasor diagram of XL, XC, and the Z and R. So it's the exactly same diagram, only instead of XVL we will write XL, instead of VC we will write XC, instead of VR we are going to write R, instead of V total we are going to write Z. So again, tangent theta is the opposite side. Opposite side is equal to XL minus XC divided by adjacent side, which is R. So tangent theta XL minus XC divided by R. To get the theta, get the inverse. So tangent of inverse of the tangent, which is XL minus XC divided by R, is the second equation to get the phase angle difference between the electric current and potential difference, or between the total impedance and resistor. If we look at these equations, these phase angle equations, theta can be positive if VL is greater than VC or XL is greater than XC. So theta is positive if VL is greater than VC or XL is greater than XC. Which means in this case, if it is positive, potential difference leads to electric current. Yani potential difference, total potential difference, V total leads the electric current. So, but if theta is negative, how? If VL is less than VC or XL is less than XC, which means theta must be negative. In this case, total potential difference, V total, lags behind the electric current I. So then you can write the electric current and potential difference equation in terms of this phase angle difference. So electric current is, because it's the same for both generator, resistor, capacitor, and inductor. So I is equal to Im sine omega t, but total potential difference is going to be Vm sine omega t plus theta. Theta is what? The phase angle difference between the electric current and potential difference. So now let's solve some problems about our LC series circuit. The first question is a series combination of pure resistor and a pure coil. So question says that a voltage source, yani a generator, it's a generator when we are talking a voltage source, of instantaneous value. This is the equation for a generator. Remember, it was Vm sine omega t. It is the equation for a generator. But here equation is given V is equal to 20 sine 100 pi t, which means Vm is 20 volt, omega is 100 pi. It's connected across a series combination of pure resistor of resistance, so R is given, which is equal to 100 ohm, and pure coil of self-inductance 0.2 Henry. So L is equal to 0.2 Henry. So calculate the total impedance. Z is the question. And the phase angle difference between the electric current and total potential difference, theta. Calculate theta. So Z can be calculated by equation root of R squared plus, remember it was XL minus XC squared, but in this circuit there is no XC, that's why you are going to write here 0. So then your equation will be Z is equal to root of R squared plus XL squared for calculating total potential, total impedance. Next step is to calculate theta. Theta is, remember, tangent negative 1 XL minus XC divided by R. Because XC is 0, so you can get it by theta is equal to tangent negative 1 XL minus R, XL divided by R. So then you need to know what XL is. XL is not given, L is given, so we can calculate XL first. We should calculate XL first. XL is equal to, remember, omega times L. Omega is given 100 pi, so 100 pi is equal to almost 3.14 times 100. So 100 times 3.14, pi is 3.14, multiplied by L is 0.2. Let's calculate XL, 100 multiplied by 3.14 multiplied by 0.2, which is equal to 62.8, which is almost 63 ohm. XL is 63 ohm. Now let's calculate first Z, total impedance. Z is equal to root of R squared, R is 100, square of 100, plus XL squared, which is 63. squared. Okay, let's calculate it. 100 squared plus 63 squared, which is equal to this number. Then after we are going to get the square root of this number, which is equal to 118. Z is equal to 118 ohm. This is the total impedance of the circuit. Then theta. Theta is equal to tangent inverse XL divided by R. XL is 63 divided by R is 100. So let's get this. First get 63 divided by 100, which is equal to 2. Then after that inverse, shift tangent -1, answer, which is equal to 32 degrees. So then theta is equal to 32 degrees. We got the phase angle difference, which is 32 positive. We got the impedance. Even we can write equation for electric current and potential difference of this circuit like this. So I is equal to Im sine omega t. So I am willing to calculate, but I will not calculate it. You can calculate on your own if you want. So sine 100 pi T is the electric current, but potential difference equation for total. Potential difference equation will be like this. Vm sine 100 pi T plus theta. Theta is how much? 32 degrees. Of course, we should write in radian. So 32 divided degrees or radian, you can add it here. So this is not asked in the question, but you can, if you want, you can write the expression for electric current and potential difference too. Next question is question about the again section of the item 1 or question 1. If the source in item 1 is connected across a series combination of a pure resistor of resistance 50 ohm and a capacitor. Now instead of using an inductor, we will connect a resistor and a capacitor in series. So a resistor and a capacitor will be connected in series. Resistance of this resistor is 50 ohm. Capacitance of this capacitor is given 2 microfarad. So calculate the total impedance again. What is Z for this combination? Calculate this. And again, calculate the phase angle difference between electric current potential difference. So again, the same method for the first one. Is for Z, we need to use equation of R squared plus XL minus XC squared. But here XL is 0 in this question, so then you are going to get the square of XC. So that's going to be R squared plus XC squared. For theta, tangent inverse XL minus XC divided by R is the equation. Because XL is 0 in this question, theta is going to be tangent inverse negative XC. Don't forget this negative, this is important, divided by R. Okay, first we should get what XC is. Okay, we will calculate XC. XC is 1 over omega C. So omega was 100 pi. So then I'm going to write 100 times 3.14. C is given 2 microfarad, 2 times 10 to the power of -6. But don't forget the bracket for calculating. So let's calculate what XC is. 1 divided by bracket 100 multiplied by 3.14 multiplied by 2 times 10 to the power of -6. Close the bracket. So the answer is 1592. So 1592 ohm. This is the XC. Now we can calculate Z. Z is equal to root of R is given as 50, square root of 50, plus square root of 1592. So square root of this number plus square root of 50. Answer is that, get the square root. So 1000, that is equal to 1593 ohm. And then theta. Theta is equal to tangent inverse negative 1592 divided by r, which is 50. Let's calculate it. So negative 1592 divided by 50. After that, shift inverse answer, which is equal to negative 88. Theta is equal to negative 88.2 degrees. This is the phase angle difference between total potential difference and electric current. According to this negative sign, it says that we total lags behind I by 88.2 degrees. This is the solution of these two problems. Now we will connect this time a voltage source of instantaneous value. Again, generator. This is the equation for generator. V is equal to 20 sine 100 pi t is connected across an RLC series. Now we connect them all. 3 devices: resistor, inductor, and capacitor. All three are connected in series to a generator. So whose equation is V 20 sine 100 pi t. R is given as 20 ohm. L is given as 2 times 10 to the power of negative 3 Henry, and C is given as 4 microfarad. Calculate total impedance again, Z is the question, and phase angle difference, theta. Now we will use the equation again, but we need to first calculate what XL is, what XC is, otherwise we cannot calculate Z. So XL, omega is 100 pi again, the equation is given. So XL is equal to omega L, which means 100 times 3.14 times 2 times 10 to the power of negative 3. So let's multiply them all. 100 times 3.14 times 2 times 10 to the power of negative 3. So this is 0.628. XL is 0.628 ohm. This is XL. XC, let's calculate it. 1 over omega C. So, and 1 over omega is again 100 pi 314. Let me write it. C is given as 4 microfarad, 4 times 10 to the power negative 6, don't forget the bracket. 1 divided by bracket 314 multiplied by 4 times 10 to the power of negative 6, close the bracket. And it is 96 ohm. It is the X. See, one of them is XL, the other one is XC. Okay, now we will calculate the Z. Z is equal to R squared plus XL minus XC square root. So R is given in the question as 20, root of 20 squared plus XL is given as, we just calculated as 0.628 minus XC is 796 square root. So let's do it. So it is equal to 20 squared minus bracket 0.628 minus 796 close bracket squared. This is the answer I think there's a mistake with it. Let me check it. It mustn't be negative once again. So 0.628 minus 796, close the bracket, but squared is equal to this, plus 20 squared, which is equal to that number. After that, get the square root of this number, square root of answer, which is almost equal to 795.6 ohm. This is Z. And theta is equal to tangent inverse XL minus XC divided by R. Theta is equal to tangent inverse. XL is 0.628 minus XC is 796 divided by R, which is equal to 20. So then, let's do it. 0.628 minus 796 divided by this number 20. This is answer, but inverse. So shift tangent inverse of answer, which is theta negative 88 point almost 6 degree. So as you see, potential difference V total lags behind again. Lags behind. Why? Because it's negative. Lags behind electric current in this circuit. So this is another question we solved about the RLC series circuit. Now we will continue in the next lesson how to solve semester exam questions about RLC series circuit.